Hello everyone, we're going to go ahead and do an example torque problem. Now what I have is a force here, F1, and it's going to be 40 newtons, and it's 0.8 meters from this end of this stick. And then there's another force over here, I'm going to call it F, that's acting at a 120-degree angle, and we want to know how much force should be applied here at that angle so that this thing doesn't rotate. And this distance from this force to here is 1 meter. So basically, if this is not going to rotate, I don't want either of these forces to be able to cause rotation, which means I want a net torque to be 0. So if we can find torque 1, I'm going to go ahead and I'm going to call this one torque 1, and torque 2, we want these to be equal and opposite to each other. Well, torque 1 is equal to the force times the lever arm times the sine of the angle between them, but since this is a 90-degree angle, the sine of 90 is 1, so this is just 40 times that 0.8 meters, which is 32 Newton meters. Now this is a clockwise torque, so if I wanted to I could call it negative. Now since I want 0 to equal T2 plus T1, I basically just want T2 to equal the positive version of this. Since this is negative, whatever. I want T2 to equal also 32 Newton meters. Now, I'm going to do the exact same thing. 32 is equal to F times R. Be careful here, the radius is from the axis of rotation, so that's 1.8 times the sine of the angle between them, the sine of 120 degrees. Now, this is a little bit interesting because remember from before I said we could extend this force back until we could draw our arm perpendicular to that force. Wouldn't that mean I want to use 60 degrees? Okay. Well, it turns out it doesn't really matter with sine. The sine of 120 is equal to the sine of 60 degrees. Alright, so that means let's just take 32 divided by 1.8 times the sine of 120. Well, 1.8 sine 120 is equal to 1.56, so I have 32 equals F times 1.56. Now I want you to notice something about that. This 1.56 is less than this 1.8. Effectively, by pushing at an angle, we've shortened our lever arm and it's not as effective as causing torque. So when I take my 32 divided by 1.56, I see that I need 20.5 newtons of force, as opposed to if we had actually pushed perpendicular here, I would need a little bit less force, right? I would need 32 divided by just 1.8, and that would be 17.7 newtons of force. So if we had pulled straight up instead of at that angle, we would have needed less force because it's better able to cause rotation.